Examples of algebra as we go along. We will now pick examples on quadratic expression. As I've already explained during the talking part of this, quadratic expression simply means the highest power of the letter is 2. When we were discussing linear equations, I told you none of the letters have any power except power 1. They are all linear. But in quadratic, the word quadratic simply means something raised to power 2. That is an expression in which the highest power that exists is 2. The general form of a quadratic expression, the general form is ax squared plus bx plus c. That's the general form. You call the ax squared the first term, or sometimes you call it the squared term. The bx is the linear one, which is the middle term, and then c is the constant. It is important to get your quadratic expression in this form, where it is all molded up. You rearrange it before you talk about it at all. The first term is the squared term. The middle term is the second term. The middle term. And then C is either the last term or usually the constant. It may be a number, but it doesn't have to be a number. So let's call it the last term. So all quadratic expressions are expected to be in that form. You get the square term, the middle term, and the constant. So to expand, I know that most of you must have done this in the simpler way. I'll do that on the side somewhere here. You have your x plus 5 into x plus 4, and you say that means x times this bracket plus 5 times the same bracket. So first you have your x times x plus 4, and then you have your plus 5 times the same x plus 4. That is what this expression, this bracket times this bracket. So we take each term in the bracket and multiply by the bracket here. Or if it is the other way, you can say x times x plus 5 plus 4 times x plus 5. Now if you expand this, x times x will give us x squared. Then x times 4 will give you plus 4x. Then the 5 plus 5x. And then 5 times 4 will give us plus 20. And from here, you will see that the 4x and the 5x are like terms. So we collect like terms. 4x plus 5x will be 9x. This hasn't got any term that you can add it to. 20 is also a constant. You cannot add a number to a letter. So we have x squared plus 9x plus 20. Now, what I would like you to note is the answer and what you started with. The first term is the first thing you times the first thing you will agree with me. So first term is first times first. The last term is 5 times 4. That is, it is the last times the last. Then the coefficient of the middle term. The coefficient of the middle term is the sum of the second figure in this bracket and the second figure in that bracket. 4 plus 5. Now, the reason this is so simple is because the coefficient of x here and the coefficient of x here is 1. Otherwise, what you normally say is that to get your middle term, you take first here times the last thing in that bracket and that the last thing in this bracket times the first one in this bracket, and you add up. So you get 5x plus 4x, which will give you the 9x. But if you are lucky to find what at JS3 level, which I'm sure this is for, you will discover that most of the quadratic expression you are dealing with probably have just 1 as their coefficient. So if this is 1 and this is 4, then we don't have to say 1 times any number is same number. Just add this to this and get the middle term. So the coefficient of the middle term is the sum of the two constants. What I am driving at is this. The expansion of quadratic expression should be done directly. This is very important. Encourage doing your expansion directly. Later on, we'll even go into factorization and we'll try to give that again directly because it's very, very important. You don't have time sometimes to go through all this. So we'll expand our examples directly, and I hope you will follow. A, well, we already have the answer, but we'll still go through the normal thing. X times x will give us x squared. 5 plus 4 will give us 9, and that gives the coefficient of x raised to power 1. So we have plus 9x. Then 5 times 4, 20. Plus times plus is plus, so we still have plus 20. Now in B, n minus 6 into n plus 3. So first term, first times first, n times n is equal to what? N squared. Then to get the middle term, you add minus 6 to plus 3 because the coefficient of n is 1. So 1 times any number is still the same thing. So minus 6 plus 3 will give us what? Minus 3 because they are not like terms. So you get minus 3n. Then minus 6 times plus 3, that is last thing in this bracket times last thing in the other one to get the constant of the last term. Minus 6 times plus 3 will give us minus 18. Two different signs multiplied to give minus. So minus times plus will give you minus. 6 times 3 will give you 18. And that's all. That is all. So let's have the next one. C times C to get the first term. That will give us what? C squared. To get the middle term, what do? We add the two constants here. So minus 3 plus 7 will give us plus 4. You have minus 3, you have plus 7. When you pay back the 3 you are owing, you will still have 4. So it's plus 4. C. Now note, you must put the letter plus 4C. Then the last term is minus 3 times plus 7. Minus times plus will give you minus. 3 times 7 will give you 21. Now let's try this. B times B is equal to B squared. Minus 3 plus minus 8 will give us, I hope you got it, minus 11. These two terms are alike. They are both negative. You are owing 3, you are owing 8. All together you are owing 11. So it's minus 11b. And then minus times minus is plus. Same signs multiplied to give plus. 3 times 8 will be 24. Practice expanding your quadratic expression directly. Most of the time, this is what you're supposed to be learning, not going through the whole step all the time. Now, E and F gives us an example of what we call a perfect square. Perfect square is anything in brackets raised to power 2. So these are perfect square. And the general form for the expansion of perfect square is if I can write that, let me write that somewhere here. A plus or minus b in bracket squared will give you a squared plus or minus 2ab plus b squared. Now, if you look at the expression we had before, we said the middle term is plus 4x plus 5x, which means if you have a plus b in bracket square, you have a plus b into a plus b. So you have your ab and ab. The middle term will be a times b, and then you have them twice. That's how we get the 2ab. And this formula is expected to be used. If you use it, it's not really cramming. If you use it several times, you get used to it and you don't really have to cram it. So here, I am going to use this formula here. X minus 3 in bracket square will give me, first of all, x squared, and I'm going to end up with plus 9. But the middle term is the problem I have to think about. So since you have a minus, the middle term will be minus. That is what we mean by plus or minus here. If you have plus, you get plus. If you have minus, you get minus. There is going to be 2 times the 2 terms in the bracket. 2 times x times 3. So it's going to be 2 times 3 times x to get the middle term. And finally, you have plus 3 squared, which is 9. Note that whether this is minus 3 or plus 3, when you square a term, it is still going to be positive. So minus 3 in bracket square is still plus. So your squared terms are always positive. The only thing that takes minus or plus is just the middle term. So you always have plus. So if you look at this, this is going to give us what? X squared minus 6x plus 9. And once again, if the coefficient of your x is 1, just multiply this by 2 and put it beside your x. Just multiply by 2. Once the coefficient is 1, you don't have much problem. So here, let's do this directly. This will be what? X squared plus, because the middle term is plus, 2 times 4, 8. Then you have 8a, and then 4 squared, you get your 16. That's the perfect square for you. Please, I'm still insisting that when you get your textbook, practice this expansion directly, because later in SS, you are going to find this very, very useful. You're going to move further into expansion of quadratic expression, and all this would have been assumed that you've done them. The big